Hello. Um, okay, so I'm Corinne. I'm a physics tutor at IU, and I am here today to explain to you the difference between binary and decimal numbers, and then how to convert between the two once we have a good understanding of what these guys actually are. So, even though it might seem a little silly, I'm first going to go over decimal numbers, and this does not mean numbers that have a decimal place. So the deci comes from the fact that we're counting in powers of 10, and it's the normal way that we count. So these are just our normal numbers that we're used to. So we count, our base is going to be from 0 to 9, which means that that allows us, or requires us, I should say, to count in these powers of 10. So we have a ones place, which would be 10 to the 0. The numbers here can be between 0 and 9, but once we get to 9, we have to start all over in the next column, which would be the tens place, or 10 to the 1. And then once we've filled up all of the tens and all the ones, so at 99, we would overflow into the hundreds place, and so hundreds, 100, 10 to the 2, and so on and so forth. So again, this is the counting that we're super used to. And if we had a number like 12, we know that this means that we have 1, 10, and this guy means that we have 1, 2, and that's what gives us our 12. And we could also represent that in our columns. Oops. By saying that we have a 1 in the tens place and a 2 in the ones place. So again, this is kindergarten, first grade stuff, but I think it's good to review how decimal places or decimal numbers work and how they're structured so that we can then go on to talk about binary numbers. So binary numbers count in that each place can have either a 0 or a 1. And this comes from the fact that when we have digital information and digital, sound files and things like that, we're often dealing with electrical currents that can either be switched on or switched off, which would also correspond to a 0 or a 1. So because we can only be at 0 or 1, that means that instead of counting in powers of 10, like we could when we would count from 0 to 9, we're counting in powers of 2. So we'll still have a ones place. That would be 2 to the 0. But instead of having a tens place, we're going to have a 2, be 2 to the 1, a 4, 2 to the 2, and I'll take this out to 8. I'll go all the way to 16. So 8, 2 to the 3, and 16, 2 to the 4, and again, this would go on for infinity. And these could be 0 to 1, 0 to 1. So if we overflow or get to 1 in the ones place and then we want to go to a 2, then we would actually write that as a 1 in the twos place and a 0 is in the ones place. But if we wanted to go up to 3, then we would need 1, 2, and 1, 1, and that would give us 3. So let's talk about then how we would represent 12 and convert that into binary. So we're back to our 12. So I typically start by breaking up the 12 into smaller chunks, and these chunks need to be one, split up into these numbers that are our twos places that we're allowed to have. So 16 doesn't fit in 12, so we're not going to include that one. But we can fit an 8 in 12. So if we have 1, 8, that leaves us with 4 left. 4 just so happens to be a power of 2. So then we would say that we have 1, 4. And then just for being really thorough, I'm also going to write that that means we have 0 2s and 0 1s, since those are the two other places that are left. So I would then kind of fill in this chart of that, meaning we have 1 8, 1 4, 0 2s, and 0 1s, and then this is our binary number that's equal to 12. So 12 is also the same as 1100 in binary. Okay, and then the other way around I think is kind of self-explanatory a little bit. I probably shouldn't have circled that guy. Oh well. But if we want to go the other way around and I give you a binary string, so let's say I give you 10101, what is the decimal number for this? I would just start from the ones place, 1 0 1 0 1, and then I would say I have 1 times 16, 0 times 8, 1 times the 4, 0 times the 2, and then 1 times the 1. Squeeze it in there. So we'll have 16 plus 4 plus 1, which is equal to 21. So 10101 could be written as 21 as well. Well, hope that helps. Until next time.